Hello everyone, today we're doing Chapter 8, Section 2, Day 2. This section will cover unit vectors. The definition of a unit vector is that it's a vector that has a magnitude of 1 unit length. Any vector where its magnitude is 1 is considered to be a unit vector. But we have two special types of unit vectors. These are some of the easier and most useful types of unit vectors. The first one is called the I vector. If we are to just write the I vector in component form, the I vector would have a component form of 1, 0. So if I was to graph that, it's very easy to graph. Like all of our component form vectors, they start at the origin, and the I vector would go 1 unit to the right. So it's a little tiny vector, it's only 1 unit long. Like that. Okay. The other vector is the j vector, and as you may have guessed, if the I vector is our horizontal one that goes 1 unit to the right, the j vector is going to be a vertical vector that goes 1 unit up. So if I was to draw that one on our coordinate grid here, the j vector would go 1 unit up, 0, 1. Okay. In the last part of this lesson, we're going to learn how to use the I vector and the j vector to describe any other type of vector. Okay. But before we do that, I want to show you how you can change any vector into a unit vector. You can have a vector that points in any direction, and you can shorten it into a unit vector by using one of the following formulas. So the first formula that you see here is for vector u. U represents a unit vector. You can solve for a unit vector if you take the original vector and divide it by its magnitude. Okay. Another way we can write that is we do 1 over the magnitude and multiply it by v. It's just another way of writing it. Okay, so that's the first formula that we're going to be using in our first example problem. Okay, example 4 asks us to find a unit vector u. They're going to use that same name u for all of our unit vectors. They want it to have the same direction as this vector v. Okay, so if we could find the magnitude of v, all I have to do is take the original v and divide it by its magnitude, and that'll turn it into a unit vector. So let's start. First we need to find the magnitude. So we're going to say the magnitude of v. If you remember our magnitude formula from yesterday, that was the square root of each of the components squared. It's basically our distance formula, but because this vector is in component form, it is its initial point is at the origin and its terminal point is at -2, 3, and so we can just do the actual terminal points. So -2 squared is 4, and 3 squared is 9. So we find that the magnitude of this vector is the square root of 13. Now I'm going to take this magnitude and use my unit vector formula. I can find a unit vector. If I take the original vector v and divide it by the magnitude of v. The magnitude of v here was the square root of 13. So I'm going to take each of these components and divide them by the square root of 13. Okay, this is now a unit vector, and it goes in the same direction as our original vector did, but it's much shorter. Okay, we can confirm that this is a unit vector by taking the magnitude of the unit vector now. So instead of taking the magnitude of v, if I want to check my answer, I can take the magnitude of u, and it should equal 1. So we're going to use the same formula. We're going to do the square root of -2 over the square root of 13 squared plus 3 over the square root of 13 squared, and we get the square root of 4 over 13 plus 9 over 13. And when we add, they already have common denominators, we add 4 plus 9, that's 13 over 13. And the square root of 13 over 13 is the square root of 1, which is 1. So yes, this is a unit vector, we did it correctly, and this would be our actual answer. This was just a check to see that we got it right. Okay, find the unit vector for 4a and 4b on your own. Okay, if you did these correctly, you should have gotten that the magnitude of vector w was the square root of 40. And when you plug that into the formula, you divide that into the original component form. So I did 6 divided by square root of 40 and negative 2 divided by the square root of 40. Make sure you simplify the radical, so that actually simplifies to 2 square roots of 10. And then you'll see that your fractions actually reduce. 6 over 2 reduces to 3 over 1. And negative 2 over 2 reduces to negative 1 over 1. So you get 3 over root 10 and negative 1 over root 10. Same thing for 4b. You should get that your magnitude is square root of 80 or 4 square roots of 5. Divide both of your components by the simplified radical. You get negative 1 over root 5, comma, negative 2 over root 5. Remember, if you want to check any of these, you can just take the magnitude and it should equal 1. Okay. Alright, next problem. The last example that we have today is to write a vector as a linear combination of unit vectors. And remember when we talked about the unit vectors I and j? That's exactly what we're going to do for these problems. So the first part is exactly what we did yesterday. They're going to give us an initial point and a terminal point, and we're going to have to rewrite this with the initial point starting at 0, 0. So we're going to basically use our formula to rewrite it in component form. So for this first example, vector DE starts at D and terminates at E. So we're going to say that vector DE can be written in component form if I do the terminal point 4 minus the initial point negative 2 and the terminal point 5 minus 3. So we change that to addition. This is 6 comma 2. That is my vector for DE in component form now. So starting at 0, 0, ending at 6, 2, that's my vector DE. But they don't want us to write it in component form. They want us to write it as a linear combination of the vectors I and j. So remember, vector I represents 1 unit in the x direction. So we are actually traveling 6 units in the x direction, right? We're moving 6 to the right. So we can actually write this as 6 i's plus, we're going to move 2 units in the y direction upward. So that would be 2 j's. And so this is just another way that we can write vectors in terms of the unit vectors I and j. If you want to, you could check your answer by replacing I and j with their unit vectors. Remember, vector I is just the unit vector 1, 0, and vector j is the unit vector 0, 1. So if I was to plug those in and multiply by the scalars 6 and 2, 6 times 1, 0, plus 2 times 0, 1. 6 times 1 is 6. 6 times 0 is 0. 2 times 0 is 0. 2 times 1 is 2. When we add these two vectors together, it goes back to the original component form we had, 6 comma 2. So this is really the same thing as our component form 6 comma 2. Okay, this is just another way of writing it. Try these two on your own. Okay, if you found the component form correctly, you would take 2 minus negative 6 for the x component and 5 minus 0 for the y, and get component form 8 comma 5. As a linear combination of I and j unit vectors, that would be 8 i's plus 5 j's. For 5b, works the same way. We get a negative for the first time, so negative 4, 9. It works the same way though. We just multiply I by negative 4, and we still have our plus 9j. Okay, those are the only examples for today. Have a great night, guys. I'll see you tomorrow.